Our next chapter has to do with logarithms and exponential equations. Right here, I've written 3 exponential equations, and the first 2 are actually things that we could figure out. So let's take a look at this first one. We have 8 equals 2 to the x plus 4. Now normally, for other equations, we've had x down here, but right now it's an exponent. One way that we could do this is take a look at this 8 and prime factorize it. And when we prime factorize the 8, we end up getting 2 to the third. And now, in order for these things to be equal, well, that would mean that these exponents would have to be equal. So the 2 ends up not mattering, and I could say 3 equals x plus 4, and subtract the 4 and get -1. And this works out pretty good. But it works out pretty good because when I prime factorized the 8, I ended up with a base of 2, which happened to be the same base that I had here. So we need to take a note of the form that exponents take. If I have a to the b, a is called my base, and b is my power, or my exponent. Let's take a look at this second example here. I have 3 to the x equals 81. And if I prime factorize 81, I'll get 3 to the 4th. And that works out pretty good for this problem, 3 to the 4th, because now I have both base 3, which means that these exponents must be equal. So x equals 4. No problems. But now let's take a look at this example. If I prime factorize the 9, I get 3 squared, and now my bases are different, and I'm stuck. So the whole basis of logarithms is I need a way to get this x out of here and down here where I can solve it like I'm used to. So that comes down to inverses. And the idea of inverses is always to undo something. So I need a way to undo exponents. That's what I need. And that's where log comes in. Logs undo exponents. So let's take a look at the way that we write an exponent again. So if I said x equals a to the b, I could write this with a logarithm and say log base a of x equals b. Now, where do I get that? For now, this is just going to be something that we memorize. But right here, this is my base. And right here, this is my exponent. So take a look at where they go. I can go back and forth either way, but my base ends up being this bottom little number of the logarithm, and this x ends up being what we call the argument. I'm taking the logarithm of x in base of a. On our calculators are programmed in base 10. And so it assumes that our base is always 10, and that's something that we'll deal with a little bit later. So let's take a look at how we actually could use this. Here we have an exponent, and I can write this exponent as a logarithm. This is my base right here, and this is my power, or my exponent right here. So my logarithms take this form, log, and here's my base. Right here goes my answer, if I were to get an answer for this, and that should equal my exponent, or my power. So, right here I have 4 to the third, so I'm going to need to fill this in. 4 to the third is actually 64. Now I'm ready to write it as a logarithm. So to write this as a logarithm, identify my base. My base is 4. So I write log, my base is 4. Now my answer was 64. So 64 goes right here, that equals 3. 3 is my exponent going out. So notice that the logarithm does take out the exponent from this. Taking a look at example 2, we can simplify this down and we say that equals 3. But I'm asked to write it as a logarithm. So what do I do with this radical? Well, I can rewrite that radical. This is a 2 right here because I'm taking a square root. So I could rewrite this, and this is my exponent of a 1. 9 to the half equals 3. So 9 is my base. 3 is my answer. And this 1/2, that's my exponent. So when I write this as a logarithm, that's log base 9. This is a little 9 going down here by the g of 3 equals 1/2. My exponent comes out. Right here, I have 10 to the 4th, so I'm going to finish that off. That's a 1 with 4 zeros after it. If I'm writing this as a logarithm, this is log base 10 of 10,000 equals 4. Notice my exponent is coming over here on the other side of the equal sign. So our calculators are programmed in base 10, and our number system is base 10. So we don't really need to write the 10 in this case, because if it's not there, we assume it to be a 10 anyway. So this is an assumed 10. The cube root of 64 is 4. If you don't know that, you can figure it out on your calculator by typing 64 caret 1 divided by 3. That will give me the third root of 64 equaling 4. This is log base what? Well, my base, if I rewrite this, that's 64 to the 1/3 power equals 4. So my base is 64. My answer was 4 equals 1/3. And now I've written that in exponential or in logarithmic form. So each of these were our answers for this question because I've changed an exponential into a log. Let's take a look at the next way. We need to be able to go back and forth. So sometimes we start with a logarithm, and I want it back in exponential form. And we're going to need to get used to changing back and forth between these. So I need to identify my base first, and this is red. Log base 2 of 8 equals 3. So my base is 2 to the 3rd power equals 8. This is my base, and this is my exponent, equals 8. And this holds true. This is correct. Right here, this is red. Log base 3 of 81 equals 4. This is my base. So 3 to the 4th power should equal 81. Notice how when I go from a logarithm into an exponent, this number is my exponent. This number became my exponent. So right here, this one's not solved. What does this equal? Well, I don't know. Let's just put an x there for now, and we'll figure out what that should be later. So my base is 4, so 4 to the x should equal 2. And now I might wonder, well, what could that x be? 4 to something equals 2. I might think, well, square root of 4 is 2. Or 4 to the 1/2 is 2. So I can put in, or write, log 1/2 equals 2 to finish that. Right here, again, I don't know what this is. My base is 5. 5 to the x equals 3. And I'll stop right here because I'm not certain that there is a root I can take right off the top of my head. That will give me 3. So this is fine to stop for now. I've switched from logarithmic form to exponential form. But what we really want to be doing with these is actually getting that number where we stopped. What does this actually equal? How do I evaluate this log? Our calculators are programmed at base 10. So if I wanted log of 3, and there wasn't a 27 there, that would be fairly easy. I'd just bring up my calculator, and I would type log, which is found right here, log 3, and my calculator would give it to me, and this would be my answer if it was in base 10. Pretty simple. But I'm not in base 10. In this one, I'm in base 27. So I need a way to get it in this a form that my calculator can use. That's where the change of base formula is going to come in. The change of base formula says that if I have a log a b like this, see how this little a, or my base, is at bottom? Well, I will write that at the bottom, log a, and I'll write this b at the top, b. A went down, b went up. My base right here, if it's not written, is assumed to be 10, which is a way that my calculator could do this. So how could I figure this out? Well, I'd write log 3 on top over log of 27 on bottom. Now I'll just put this on my calculator, and if I need to, I'll round. So I will put parentheses, and I'll write log, and I wanted specifically log of 3 on top. So 3, all right, that gives me log of 3, and I'm going to divide that by log of 27. These parentheses are going to be important, so my calculator does everything in the right order. I'll press enter. I get 3 repeated, and that's going to be one that we want to remember. I could write this as, and I probably moved that a little bit. I didn't want to do that. 0.3 repeated is something that I could write as 1/3. So I'm going to write 1/3 right there. Okay, let's take a look at this other one, log of 10, or log base 121 of 11. I'm going to write log of 11 on top and log of 121 on bottom. So I have log of 11 over log 121. So I'll type that in, and this time I'll do it in a different order. So again, I wanted log of 11 over log 121. So we'll write log 11. I'll press enter. All right, now I'm going to divide that by log 121. This is just a different way to put it in my calculator. I get 0.5, which we should recognize as a half. So this one equals 1/2, or 0.5. Okay, so now I'm going to take a look at this one right here. Not this, this one. So how do I get that? Well, log 64 on top. Again, this number is going on top, this one on bottom, over log 4. So I have log 64 over log 4. Now I'll go to my calculator. I already forgot. Log 64 over log 4. So log 64. And now divide that by log of 4. Should probably close off that parenthesis. And I get 3. Now I don't have to rely on my calculator. I could do this without my calculator. I'd write equals x. And I'd say log, well, I'd say base 4 of x equals 64. And I would prime factorize both of these. 4 is 2 squared. 64 is, what is that one? 64, 8, 2 to the 6th. So 2 to the 6th. Power to a power, multiply. And these would be equal. And I get 3. But this is probably a lot of algebra that we don't need to be doing. So we can use the change of base formula instead. Way easier. All right, last one. Now I do have these fractional bases. So I'm going to write log of 1 over 81 all over log of 1/3. Okay, so I'm going to be very careful with my parentheses, and this time I'm going to type it all in at the same time. So I'm going to have log of 1 over 81 close my parentheses, divided by parentheses log of 1 over 3 over 3. Try that again. I missed a parenthesis. That's not good. I'll have to type that in again, I guess. So put an extra parenthesis right here. Parenthesis. It's probably going to delete everything. Yep. 1 divided by 3. There's probably a better way to change that. All right. Got that in. And I get 4. So this equals 4. All right, just 2 more questions to do, and then we have completed this. So again, we are evaluating the logs. All right, so we have right here base 8 of 512, let's say equals x. All right, so change of base formula, log of 512 on top, log of 8 on bottom. Go to my calculator and type that in. So log 512. And then we divide that by log 8. Get 3. So this one's 3. Right here, change the base formula. So this number goes on top. This number on bottom. This is base 10, which is what my calculator is programmed in. So I type in log 169. And I can divide that by log 13. Get 2 equals 2, which should make sense. Let's go ahead and change this. So if I have log 13 of 169 and I say equals x, let's change this to exponential form. This is my base, 13. This is my exponent, x, equals 169. I'm thinking, what could I put here that would make 13 times itself be 169? And according to our work, a 2. Another way to get that, prime factorize that 169, and I get 13 squared, and the x must equal to 2.